Now we have the WT90 completely configured with cards. We have an Ethernet card in slot 1 and a Wi-Fi card in slot 2. This is our WBW2000, which is a 3x3 MIMO card. What this section of the video will go over is connecting an access point to the wireless card into the Ethernet card so you can prepare for testing. I'm going to do first the case where we have an access point that is that you're going to cable up on a tabletop. The next step we'll go to is how to put this same device in an RF enclosure. But in many cases you're trying to test on the tabletop, or maybe you're in an RF enclosure already. So we'll just talk about the cabling pieces of RF first. This access point has 3 antenna connections. It's a 2 spatial stream access point. It'll do what's called 2x3, transmits on 2 antennas and receives on 3. But it can handle up to MCS 15, which is a 2 spatial stream MIMO configuration. So the way we're going to connect is primarily you'll have an antenna port A and an antenna port B, and frequently you'll have an antenna port C. But A and B you will connect to ports A and B on the MIMO card, as simple as that. So what you need to do in order to make those connections is take an adapter. Once you've removed the antenna from the access point, assuming it has a removable antenna, and you're going to use a reverse TNC to SMA adapter. Other APs use a reverse SMA to SMA adapter. Both of these are included in the kit that comes with each wireless card from VariWave. In this case, it's a reverse TNC to SMA adapter. So what we're going to do is first check to make sure that the pieces are going to mate together correctly. So there's a male pin down inside of this reverse TNC connector. There's a female receptacle here. Those are going to go together fine. And we'll go ahead and screw this adapter on port A. We'll screw an adapter on port B. And we'll leave port C for you to do on your own. The next thing we do is attenuate the RF signal between the access point and the blade card. 802.11 radios are typically designed to be broadcasting over the air. So this access point puts out signal levels that can go from 0 dBm to plus 15 or more dBm. And so they put out a very powerful signal. The receiver side of all these 802.11 systems are really expecting a signal that's down in the minus 25 dBm range, because they are typically communicating with each other over the air. And of course, when you go into the air, you lose 20 to 30 dB just by going through the air. But now, since we're cabled up, we could easily, by just using a cable between the RF connection on a blade card and an RF connection on the access point, we could overpower both receivers. And so what we do is we put an attenuator. These attenuators are provided, again, with the cards that you buy from VariWave. The one I've chosen here happens to be a 30 dB attenuator. 20 dB will work as well. And you're going to place the attenuator on the access point, not on the blade card. The reason is the blade card puts out power that is from 0 dBm to minus 50 dBm. So it's a less powerful card than an access point is. The access point tends to put out somewhere between 0 dBm and plus 15. So what we want to do is attenuate the signal as it comes out of the access point, so that now we minimize the chance of any signal getting out of our cables and into a neighboring test setup. So you're going to take the attenuator and you're going to mount that onto the access point. Again, you're going to check to make sure that the pin and receptacle are proper. And when you attach the attenuator, you notice that I would turn the nut on the bottom of the attenuator. I'm not going to spin the entire attenuator. If I spin the attenuator on, I'm spinning the pin as well, and I'm wearing the pin against the socket, which wears it out. So to get the best connection and longest life out of your RF components, you really want to hold them gently and turn the nuts in order to adjust them down. Don't spin the whole device. Okay, and so I'm going to put one of those on this port A. I'm going to also put an attenuator, and I'm going to use the same 30 dB attenuator in both cases over on port B. these need to be very, not overly tight, but they need to be tightened properly. And you tend to go get a torque wrench and tighten them down correctly. If you don't have a torque wrench, tightening them firmly by finger is just fine. That'll work out just fine. So now I'm going to connect up a cable to see what that looks like, and then we'll allow you to connect the rest up yourself. So of course what we're going to do is use good quality RF cable. This is double shielded cabling, and it provides ample signal transmission between the access point and the blade card, but it also provides very good isolation to keep one test situation from interfering with the other. So again, we're going to tighten the nut, not spin the cable, and tightening that. And then the other thing we do with RF cables is we allow them to drape naturally. We don't want any kinks or tight bends. We would like for the cable to be relaxed so it can be easily connected and that there is no stress on the cable. Again, you want to tighten it as hard as you can with your fingers, or use a torque wrench, which is even preferable, in order to snug these down. Then you would just repeat the same thing with port B. Here we'll connect port B of the access point to port B of the MIMO blade. Again, using the torque wrench to make sure things are good and snug. You notice that the cables are making a very gentle bend, no kinks, no tight turns, etc. Now the last thing we would do in order to test this access point, of course now we have a radio interface that is ready to go. We would then connect from the Ethernet port of the access point to the Ethernet port on the test side of the blade card, or you could connect between this port and a switch, which is the way I've got it set up. So you're going to go ahead and connect that up. And again, remembering that this connection is to the device under test. This radio connection is to the device under test. That's different than the Ethernet connection on the back of the chassis, which is used to connect to the PC where I'm running the wave test application. So next what we'll do is show you how to put the same situation into an RF enclosure.